What's up, mathletes? This is section 3.4, solving quadratic equations by factoring. You're going to see a bit of a departure here from what you remembered in Algebra 1. When you were solving equations in Algebra 1, it was pretty straightforward. All you had to do was undo the subtraction, undo the multiplication, and you got your answer in a couple of steps. But that's really not going to work for when it comes to more complicated equations, especially ones that have higher exponents. We really have to do something completely different. And so what we have to think about are these first two ideas that are going to help us sort things out are going to be the idea of factored form. So for example, if you can get an equation into this kind of format, then it's going to be much easier to solve. So if you can see 3x plus 1 times x plus 2 is equal to 0. In this format, let me tell you, generally it's one giant term and it's all set equal to 0. So there's no like plus 4 on the outside of parentheses over here, plus another x. It's just the one giant term that has two different factors separated with multiplication contained inside parentheses. And then the factors here, each individually, have got to have an exponent of 1. Like this, it can't be 3x to the fourth power, 3x squared. It's got to be 3x to the first power, exponent of 1. X to the first power plus 2 is... those are the factors. Now, if you get an equation into this format, then it's going to be a lot easier to solve because of the second idea. The second idea is the zero product property. And if you have a times b is equal to 0, like two different things that are multiplied by each other then equal to 0, then you could say that either a is equal to 0 or b equals 0. Like basically, oh, I'm thinking of two numbers in my head. And when you multiply them up, you get 0. And then the person listening is just like, well, either the first number is going to be equal to 0 or the second number is equal to 0, or maybe both of them are equal to 0. But these two ideas taken into tandem are going to help us solve more complicated equations that have like higher exponents. And in the course of our study, we are going to run into we might have to take the square root of a negative number, and that's the whole reason. The whole reason why we spent the past couple of days really getting good at complex, like imaginary numbers and complex numbers and arithmetic and all that with imaginary numbers is because when we do section 3.4, we might have to take the square root of a negative number, and at that point, we'll be ready. All right, example 1, factor by distributive property in GCF. So here I got 3u squared minus 15u is equal to 0. Oh good, it's already equal to 0. I've noticed here that there's a greatest common factor, 3 and 15. Greatest common factor is 3. Even with the variable portion, u squared and u, the greatest common factor is u. So overall, the greatest common factor between these two different terms is 3u. So I can factor that out. 3u goes over here and on the outside, and I could ask myself, 3u times what gives me 3u squared? Oh, well, that's u. 3u times what gives me 15u? That's 5. And since there's subtraction here, there's also subtraction here. We get all this is equal to 0. If you wanted to check that step, you could just distribute. This is, in fact, factoring is the reverse of distribution. And so if you wanted to go, like this is the question, and this is the first step of work. And if you wanted to figure out whether or not, or double check yourself, figuring out whether or not you did it right, you could actually distribute. 3u times u is 3u squared. 3u times 5 is 15u. And we're back to the original. But actually, we don't want to distribute. We want to go in the opposite direction, and that's factoring. So this is now in factored form. We've got one big thing times another big thing is equal to 0, which is great. 3u times u minus 5. Because it's in factored form, we can use the zero product property, and that 3u is the first big hunkin' thing, and the u minus 5 is second thing. And if thing 1 times thing 2 is equal to 0, then both of those things could be equal to 0. So in this case, 3u could equal to 0, or u minus 5 could equal to 0, which is great, because these are now we've basically taken something that's complicated with an x squared, with a exponent of 2, and we turn it into something that we've seen in Algebra 1. Wait, we're taking something that we don't know how to do and turning it into something that we do know how to do. 3u is equal to 0, or u minus 5 is equal to 0. We've got Algebra 1 skills, and we can solve those. And so we can say that u is equal to 0, or u is equal to 5. There are two solutions to this equation. Here they are. U could be 0, U could be 5. And we're going to put them inside these curly brackets. Because there are two solutions, we have to report them both. There are two answers to this, not just one answer. So let's report them in a big set, 0, 5. This is the set notation. Two answers, 0, 5. All right, let's do this again. Factor by distributive property and the greatest common factor. Wait a minute, 4 and 8. The greatest common factor is going to be 4x. And so I can pull that out, put the greatest common factor on the outside of a set of parentheses, and you ask yourself, 4x times what gives you 4x squared? X. 4x times what gives you 8x? That's 2. So we've got 4x times x plus 2, which is now in factored form. Two different things multiplied by each other. They're separated by multiplication, and they're all equal to 0 with no other extra terms, no other addition out here. So we can use the zero product property to say that 4x could equal 0 or x plus 2 could equal 0. Great, because now we can solve that. Undo the multiplication, undo the addition, you get your answers, you put them in a set of curly braces. 0, negative 2. So this is the set, it's the collection of all the answers, and there's 2 of them here. Here, the greatest common factor. Oh, before I can find the greatest common factor, I know I've got to set myself up for, I've got to put everything on one side. It's all got to equal 0. The whole thing just falls apart if it is not equal to 0, if it is not completely factored in factored form. So we got to move 18w over to the other side. That's some preliminary work first. But now that we've done that, we're in a great position because we can see the greatest common factor is 6w. So that's 6 and 18. Greatest common factor is 6, and w squared, and w has w. Greatest common factor is w. So we write that as greatest common factor on the outside of a set of parentheses, and you got 6w times, and now 6w times what gives you 6w squared? Oh, it's w. 6w times what gives you 18w? It's 3. So we've got here, it's now in factored form. It's all equal to 0, and you've got separating everything with 2 things with multiplication and no other terms on the outside. So we got 6w. This first part could be equal to 0. The second part could be equal to 0. Use your Algebra 1 skills to solve to get 0 or 3. Same thing over here. W squared is equal to 11w. Well, the greatest common factor is only going to be w. You can see that after you move it to the other side. And so pull out the w and set them equal to each individually equal to 0, and you get 0 or 11. There are 2 answers here, and you can report them both. All right, now solve that's really great if there's just 2 terms, like the x squared term and the quadratic term and the linear term, the x squared and the x. But what happens if you have this additional number, 25? It gets a little bit more complicated than that, but that's okay because we're ready for it. If the overall format of the strategy for doing this is going to be, first you got to find the factor pairs of C, which is 25. In this case, it's that third term. You choose the pair that adds up to B and split the middle. Let me just show you what it looks like. X squared plus 26x plus 25. Well, you can ask yourself what numbers times what numbers multiply up to 25? I've got a couple of pairs. There's 1 times 25 is 25, and 5 times 5 is 25. But we're going to choose the pair of factors that adds up to the b value, which is 26. And there it is. 1 plus 25 is 26. So I'm going to split the middle. Bear with me here. You're going to take this 26x and you're going to turn it into just 1x and 25x. Now I know you could combine these two. You could say 1x plus 25x is 26x, but that would be simplifying these 2 terms, but we want to split them up so that we can take the next step. The next step is going to be here. We would just take the greatest common factor of these first 2 terms, x squared and 1x. Ignore the rest of it for just a hot minute. And we can see the greatest common factor is x. We put it over here. And then x times what gives you x squared? Oh, it's x. X times what gives you 1x? It's 1. So you can factor out the greatest common factor of these 2 terms is x, and you just write x times x plus 1. You do the exact same thing for the second 2 terms. We've got 4 terms here, and so you can do this twice. greatest common factor is 25. So you pull that out. It's 25 times x plus 1 gives you what you have over here. Now, if you wanted to double check yourself, you could just to see if you're doing this correctly and whether or not you did it correctly, you can actually distribute. Distributing here gives you x squared plus 1x. Distributing here gives you 25x plus 25. So it seems like it's just things are getting weirder and weirder, and one more step of weirdness, it looks like this. Now notice, if you did it correctly, you are always going to have this set of the thing inside parentheses is going to be repeated twice. X plus 1 over here, x plus 1 over here, which is not a coincidence. If you've chosen your factor pair correctly, this will actually work. Because, and so therefore what you can do next is say, wait a minute, the greatest common factor of this giant hunkin term and this giant wonkin term over here, the greatest common factor is x plus 1. It is a factor because it's separated with multiplication, and it's in both of them. It's common to both. So I'm going to pull that one out over here. X plus 1 is the factor. And you take this x and put it here, and this 25 and put it here. And if you don't believe me, you can distribute this even as well. You could FOIL it. And foiling it would produce, let's see, the foiling first term would be x times x is x squared. The outside term would be 25x. The inside term would be 1x. And the last term would be 25. That's how you can check to make sure you've done it correctly. That's a very complicated way of doing things, but it actually works out pretty awesome because the great thing about this is now that it's in factored form. We've got, and it's all equal to 0. We got something times something equals 0. So therefore, those two somethings, thing 1 and thing 2, could both individually equal 0. And now we got x plus 1 equals 0, or x plus 25 is equal to 0. So x is equal to negative 1, or x is equal to negative 25. That's negative 1. And so the solutions to this giant equation right here, the two numbers of x that will make it work, are negative 1 and negative 25. Wow, it's a lot of work. And it's really a lot of strange work, too. But let's do it a couple more times, and maybe we'll get a bit more familiar with it. One step that I forgot to check is it's always really good to check to make sure, to see if you have any greatest common factors you can divide out. And the greatest common factor between these three terms, as a very first step, is 1, so we don't have to worry about anything. Let's check to make sure that here the greatest common factor is 1. So yeah, you can't divide anything by all three terms. All three of them. I mean, if you were just checking the last two terms, the greatest common factor would be 4. And the greatest common factor here would be u. But of all three terms, it's just 1, so we don't have to worry about, we don't have to divide anything at the moment. All right. First, find factor pairs of c, this number right here, 12. That's 12, and then, so 12 can be multiplied up as 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. And it really does help to write it out. You might think you can do all this in your head at the moment, but things are going to get way super complex in a moment. So I want you to get in habits right now that are going to help support much more complicated equations. Even if you think you can do it in your head right now, write it out, because pretty soon it'll get to a place where you can't do it in your head. So we have to choose the factor pairs of c that add up to b. So 1 times 12 is 12, 2 times 6 is 8, 3 times 4, 2 plus 6, 1 plus 12 is not 8, 3 plus 4 is not 8, but 2 plus 6 is 8, so we're going to use this one right here. So we're going to split the middle, and that's the name of the technique, split the middle. So 8u is going to get split up into 2u plus 6u. Does not matter which order you write it in. You could write it in 6u plus 2u or 2u plus 6u. It's all going to come out in the wash anyway. So finding the greatest common factor of these two terms, it's u. You write it out front, and then u times u is u squared. U times what gives you 2u? It's 2. So u times parentheses u plus 2. Plus, greatest common factor here is 6, and you get 6 times u plus 2. And if you've done everything right, at this point you will see that u plus 2 appears twice. That is a factor. It's the greatest common factor of both of these giant terms, and so therefore you can pull it out front and put u plus 2, that because it's the greatest common factor. What are you multiplying u plus 2 by? You're multiplying it by u here, and you're multiplying it by 6 here. So u plus 6. And if you've done that correctly, then you can see that if you FOILed it, you get back to the original. u squared, inside term is 2u, outside term is 6u, and 2 times 6 is 12. So foiling, we're going in the reverse direction of foiling. So if you wanted to check your work, you could foil. But we don't want to foil because it's going to take us further away from the answer. What we do want to do is factor. So using the zero product property, we can say that u plus 2 times u plus 6 is equal to 0. So therefore, split them up into this portion or this portion. And so you can see when you use your Algebra 1 skills, you get these answers, -2 and -6. Let's move on. All right, so this whole thing falls apart if it's not all equal to 0. So the absolute first thing you got to do is set it all equal to 0. Once you've done that, once you've set it equal to 0, moved the v and the 12 over to the other side, you check for greatest common factor. Still no great. I think it's going to come next, but right now the greatest common factor is still equal to 1. Split that middle. Find factor pairs of the c value, which is -12. Okay, so it's negative. It's going to get a little tricky. What numbers time themselves equal -12? You've got a whole plethora of options here. -1 times 12 is -12. -2 times 6. -3 times 4. -4 times 3, which notice is different from these two, because here it's -3 and here it's -4. -6 times 2, -12 times 1. You've got all these options here, and it's going to get tricky if you don't write it out. I think it's already tricky as it is. So make the choice and write it out, and be more sure of yourself, so you can see visibly all your thoughts on paper. Which of these adds up to -1? The b value here is -1, and it's not -3 plus 4. It's -4 plus 3, because -4 plus 3 is -1. That's how we're going to split the middle: -4 and -3. So v squared minus 4v plus 3v minus 2 is equal to 0. We're splitting up -v into -4v plus positive 3v. And when you've done that, and like I said before, it doesn't matter what order you write it in. You might get a slightly different intermediate work here, but the answers are going to be the same. When you take these first two terms, the greatest common factor is v, and so v times what is v squared? It's v. V times what gives you -4v? It's -4. Plus, greatest common factor here is 3. Pull it out, and all of a sudden you've got v minus 4 and v minus 4. It's a great check. Every time you split the middle, you're going to get two things. You're going to get this v minus 4 repeated twice. That's the same factor twice, because the next step is going to be pull out v minus 4. I put it over here. It doesn't really matter what order you write it in. V plus 3 times v minus 4 is equal to 0. Great, it's in factored form. Because it's in factored form, and because it's all equal to 0, we can use the zero product property and split them up. This factor is going to equal 0, and this factor is going to equal 0. And when you solve it, you get these two numbers: -3, 4. That's the solution set. Here. All right, so this is going to be a little bit more complicated. But that's okay. First step is set it equal to 0. Second step is check for greatest common factor. And whoa, all of a sudden I can see that all three of these numbers are multiples of -3. And it's even, just this whole process is going to get way easier if we can somehow get rid of the negative also. This split the middle process, as it stands right now, necessitates no number right here. You can see it's not 3x squared, it's not 5x squared, it's just x squared. You only have a b and c value, and the a value is equal to 1. So, lucky for us, our techniques are going to work here, because you can divide all the terms on both sides by -3. -3 divided by -3 is 1. 21 divided by -3 is -7. -30 divided by -3 is +10. And now we've got into a format, an x squared plus bx plus c equals 0 equation where split the middle is going to work. You've got to check your c value, and so c value is 10. You've got to write out the numbers that multiply up to 10. And right now it's just 1 and 10 and 2 and 5. And but when you add them together, you don't get -7. So there are a couple more pairs that you can write out. Because you're trying to get -7, you could also say that -1 times -10 is +10, and -2 times -5 is +10. And which of these adds up to -7? It's the very last one here, -7. And so we split the negative 7x into minus 2x and minus 5x. And so we find the greatest common factor, it's x. And what remains, x minus 2. Greatest common factor here is, we're going to say it's minus 5, because if you choose, you might say, well, Mr. Bergman, why couldn't it be positive 5? Well, this subtraction is really super tricky, and so I think what you could do is you could really take an intermediate step and say plus negative 5. And if you're doing plus negative 5, then you can see that this would be minus 5. You could factor out a negative 5, and you get negative 5 times negative 2 is positive 10. Anyway, when you do that, you see that you get that repeated x minus 2 and x minus 2 here. And so since it gets repeated, you can pull it out here, and what's remaining is the x minus 5. Foil it, and you would get back to this step right here. Split them up, you get x minus 2 is equal to 0, or x minus 5 is equal to 0. So x is equal to 2, or x is equal to positive 5, and there are the solutions. Now, some patterns here. The savvy student might see a connection between 1, 25 here and 1, 25 here. And you might say, Bergman, look at this. I see a 1, I see a 1. I see a 25, I see a 25. I see a 2, I see a 2. I see a 6, I see a 6. I see where is it? Oh, I see a positive 3 and a negative 4. Positive 3, negative 4. I see a negative 2, a negative 2, and a negative 5, and a negative 5. And you might say, Bergman, that's a whole lot of work. Can't I just skip down? Oh, and if you wanted to be even more savvy than that, I see 1 and 25, and all of a sudden, I could just make them both negative and get the answers right there. Holy smokes, that's even faster. 2, 6, make them negative, negative 2, negative 6. Positive 3, negative 4, flip the signs, and you get negative 3 and positive 4. Oh, wow. It always works here. Negative 2, negative 5, positive 2, positive 5. Why, Bergman? Why? Why do we have to go through the process of doing all that work when there's a shortcut? And my good students, let me tell you, the reason we got to do this is because we're building up a process and we're building up habits that are going to support more complicated equations where this pattern will not hold. But for right now, I can't show you any because we're just doing the easy version now. Trust me, please, my good students. If you trust me this far, keep on trusting me that if you build up these habits and these thought processes now, they will serve you well later when things get way more dicey. What are the solutions? Let's keep on going. There are 3 questions you can ask. What are the solutions? What are the zeros of the function? And what are the x-intercepts of the graph? And they are incredibly related to each other. Let's split the middle. Again, let's use our same split the middle techniques. We got 0 is equal to x squared minus 4x minus 45. Oh, look at this. It's already equal to 0. We check for a greatest common factor. It's just 1. So we have to find the factor pairs that multiply up to negative 45. What multiplies up to negative 45? All of these things. Negative 1 times 45, negative 3 times 15, negative 5 times 9, negative 9 times 5, negative 15 times 3, negative 45, and 1. And so which of these pairs of all of them adds up to negative 4? It's this one. So we can split the negative 4x into 2 different terms, negative minus 9x and plus 5x. When you do that, the greatest common factor is x, and then x minus 9. And then 5 is x minus 9. So you can write this out as x plus 5 or x minus 9. And when you split them up, you get x plus 5 or x minus 9 is equal to 0, and therefore here are your solutions. Great. Now, very related question would be, let's say instead of it's all an equation equal to 0, let's say it were a function. And a very common question to ask about functions are, what are its zeros? Meaning, what are the inputs that create 0 as an output? You could do the same process, the same split the middle thing right here, and find out that since the solutions of negative 5 and 9 are there, then those are the inputs, the x values that produce an output of 0. And you could even check that with an input-output table. If you put in, I'm just taking these numbers right here, negative 5 and 9, and if you put them into the function f of negative 5, plug them in, Negative 5 squared minus 4 times negative 5 minus 45 does in fact give you 0. And if you plug in 9 as an input, then the output is 0. So whenever you see what are the zeros of the function, basically just asking what are the solutions to the related equation. These are the inputs that are going to produce an output of 0. Similarly, you could ask, what are the intercepts of the graph? And maybe if you've got an Inspire handy or a Desmos graphing calculator handy, then you could just graph it and check the intercepts. But if that is difficult to do, or if you don't have access to an electronic grapher, you could do the same process. You could substitute the y for 0, and boom, split the middle. You get negative 5 and 9. And so those are the x values that are going to produce a y value of 0. And you can see negative 5 put into the negative 5 here gives you a y value of 0, and 9 gives you a y value of 0. Same functions, same answers, basically. The big idea is that equations here have solutions, and functions have zeros, and graphs have x-intercepts, and they're all very related. Solving them in factored form helps find them all. So it's just these are three different ideas that are incredibly related. Equations have solutions, functions have zeros, and graphs have intercepts. Last thing, I know you've been with me for quite a while. I know we're up to 26 minutes, but one last thing, and then we're good. Start with the solutions and write the original equation in polynomial form, meaning with no parentheses. So we're going to completely reverse the process. Here we started with something that we had to factor and get answers. Here are solutions. Here we're going to start with solutions and FOIL and get the polynomial. So you see here's x plus 5, x minus equals negative 3. Setting them both equal to 0, get x minus 5 is equal to 0, x plus 3 is equal to 0. And then using the reverse of the zero product property, you can combine them to get this, and when you FOIL it, you get this. So what does that look like here? Set them equal to 0, boom, boom. Multiply them together, boom. When you FOIL, you get this, and so that's what it looks like. Set them equal to 0, multiply them together, and then FOIL, or distribute in this case, and you get x squared minus x equals 0. That's it. Thanks for playing. I'll see you in class. Take care.